probably $3 million worth of deer in his pens. They went in there and shot every damn one of them. Then they go in there and they fine him $1 million. They're not done. And then they cut him some slack. Since he's 80 years old, instead of throwing him in state prison, they give him house arrest for 4 years. Everybody loved this guy. He's a super nice guy. And he had a business there in this little bitty town. I think he employed 650 people in this little business he had. And why would you do that? I know it's their version of like trophy hunting, to have somebody they can hang on the wall, but the only reason I come up to is because I can. When you see me saying, I'm not going to fight them, I'm just done, I'm packing my shit up and I'm going home, I've seen what they can do. And I know I can't win anyways. All right, well, welcome to the Mendota Ranch. We are going to talk about cloning today. The reason I've kind of been putting the cloning off is because I thought we'd have something to clone this year, some deer, and because it's kind of the time of year when we actually do the cloning. Except Texas Parks and Wildlife, or the great state of Texas, have made it illegal for me to clone anymore. So I'll cry about that later. Let's talk about cloning first. First things first. All right, you want to clone your animal. The first thing we've got to do is we've got to gene banking. So what's gene banking? Gene banking is when we gene bank your animal's somatic cells. So we'll take a biopsy. So anywhere on the deer, on the dog, on the horse, we take a biopsy. So the biopsy is just, you know what a biopsy is. It's, eighth of an inch deep, eighth of an inch wide. And from that biopsy, we'll take 2 or 3 of those. From that biopsy, what we'll do, grow and culture the somatic cells, and then we freeze them. And that takes 2 to 3 weeks. Once that's done, then your animal is what we call gene banked. And then you can clone him from that point on, anytime, 100 years from now, 100 hours from now, it doesn't matter. First things first, gene bank your animal. So if you got anything you want to gene bank, or want to clone, that's what you got to do, is gene bank him first. Now, why would you want to clone? So the reason we clone is to preserve the genetics of your animal. Okay? So if you've got a stallion and you've got a bunch of semen in the tank, in the nitrogen tank, well, you don't need the cloning because you've already preserved the genetics. But now if you got a great mare, you can't do that. Or a great doe, you can't do that. So then you would gene bank your doe and then produce more copies of that doe. As she's getting older, then you'd want to preserve her genetics. Well, then you'd have to make more copies of it. So in the deer business, the reason people would want to clone something, they don't want to clone the big bucks because they've got semen in the tank. They want to clone the great does. So deer breeders know genetics just like horse people, cow people. They all know great genetics, and they know great does. We call them blue hens. So a blue hen is a great doe that always produces a great buck or great offspring. So what you'd like to do is be able to have 5 copies of that doe and breed it to 5 different bucks so that you can spread your wealth out. Because if you take one doe, breed it to 1 buck, and even if you super ovulate it and you get 15 offsprings, say those 15 offsprings are only worth $500,000, well, the one would be worth $500,000, but you got 15, well, then it just dilutes it. But if you can breed it to multiple different bucks, well, then your $500,000 now turns into $1 million because it's different bucks. So that's why you'd want to clone. Okay. Now cloning dogs, like y'all seen my little dog run around cloning, and I've cloned, and we don't breed them or anything like that. But I'm telling you, it's the same dog, but it's different. Now we love our little clone dog. I mean, we actually probably love it more than the original because she has got such a great personality. But epigenetics comes in, so their personality is going to be a little different or a lot different depending on, like when we had little kids at one point, it's different when you got little kids and big kids. And so the epigenetics starts immediately once the embryo is formed. So that all aside, you decide you want to clone. Here we go. Okay, first step. I'm going to do kind of a PowerPoint here, so y'all just stick with me. I'm going to go fast. So you might have to watch the video a couple hundred times, and that's great with me. Okay, so here's the first, we're going to call it slide. Here's the first slide. This, I'll show it to you again, but this is what you need to picture in your head. You've got the cell donor, so you got to have somebody providing you the oocyte. So what's an oocyte? Okay, an oocyte is a female egg. It's in the ovary. And what we do is we take that oocyte, we mature it. Once we mature it, we'll remove the DNA. I'll show you a video of this in just a minute. Then we've got the donor. The donor is the one we've already gene banked, right? So once we get her gene banked, then we put all that together. You get your one gene banked, and then you've got your cell donor. You get that oocyte matured, remove that DNA, we implant that DNA from your donor, from the somatic cells, from what we've gene banked. And that's what makes the embryo, and it goes into what we call the recipient cow at the bottom of the page, recipient cow. She gets pregnant, and then she gives birth to the clone, okay? So let this burn in your head for a minute, and I'll show it to you at the end again, but this is what you need to picture how it works, okay? So I need to go get oocytes. We need to get the oocytes. Remember, that's the female egg. Like the sperm is to the male, the oocyte is to the female. So we go out to ranches, this ranch, other ranches around, and we'll be harvesting does. Texas Parks and Wildlife wants us to harvest so many does. So what we'll do is we'll shoot these does. Once we get them in here to the headquarters, then I'll remove the ovaries, and from the ovaries, I get the oocytes. Alright, so we've already gathered the ovaries. I've got all the ovaries out of the does. I have them in the lab. So at the top of the screen, you'll see those are ovaries. Now look on the ovaries. You see the black dots? The little black dots are what we call follicles, okay? And in the follicle, they're immature follicles. In the follicle is the oocyte. So look at the bottom of the screen. Those are some oocytes that we get out of the deer ovaries. That's what we're after, okay? So now I'm going to mature these oocytes. The neat thing about oocytes, okay, so here's the crazy thing about oocytes. I guess it's not crazy, it's kind of crazy. The sperm, so the sperm, you know, the chromosome ladder, right? The sperm has half of a ladder. The oocyte, the immature oocyte, has both sides of the ladder, right? And when it matures, half of that ladder is actually kicked out, and that's called the polar body. I'm going to show you the polar body in just a minute, but it kicks out. That's how we know it's a mature oocyte. And why it's doing that is because it's matured, and it's actually would be getting ready for the sperm. Not that we're using any sperm, but we'll get it ready for the sperm, okay? So before we mature the oocytes, we have to make the mat media, the matration media. So I'll get down here at like 4 o'clock in the morning, make it all up, because it's got to equilibrate in the incubators. So the picture on the left is the hood. And we do this all in sterile environments, because anything that will grow oocytes will grow fungus and everything else. So that hood is where we actually make all of our medias, and we make them all from scratch. And then on the right, you'll see incubators. The first incubator is what we use for maturing our oocytes. The second incubator, the farthest right one, is set up for culturing embryos. Okay, so what we'll have our media ready to go, and then once I get those oocytes, I just showed you those oocytes, they're immature, they're going to go into that media for 24 hours. And that's how we mature the oocytes. Okay, now, this is kind of important. Whenever we mature the oocyte, we want a very good maturation rate. So the mat rate kind of sets the tone of the clone and how good we're going to do. So say if we got 100 oocytes, we got 100 oocytes. Let me start. Okay, say we got 100 oocytes. We like to see 60 or 70, so 60 or 70% of them mature. If we're down around 30 or 40%, it's probably not going to be a good day for cloning. So, so the next slide you're looking at are some of the microscopes. So this is Dennis. This is a guy named Dennis that helps me a lot when I'm cloning, because it's a two-man job. The scope on the right is a micro manipulator. This is what we do. This is what does all the work for us, okay? So I'm going to show you a video next of how we remove the DNA. And what you'll see, you're going to see this oocyte with a polar body, and we actually stain it. So right now, right before this video, I am staining these oocytes, and then we're going to remove the DNA, and then we're going to put the DNA back in. So let's watch this video, and I'll talk through it. First things first, we got to remove the DNA. The DNA is, we got the polar body that's kicked out. We go ahead and remove it, and it's a cell that's right between the cytoplasm and the zona. Okay, and then remember I said we stained it. So in the stain, we use a special light, and it illuminates the DNA that's inside the cytoplasm. That needs to be removed. So you'll see it flash on, flash off. That's me removing that. Then here we go on the picking up the cells, the somatic cells, to reconstruct this oocyte. So we're going to reconstruct them. So we pick up these oocytes and we place them in between the cytoplasm and the zona. Okay, so this is the job I like to do because I'm not very good at running the micro manipulator. But so what happens next? Remember, we just got through putting the cytoplasm and the zona, and right in between those two is the somatic cell that has the DNA that you gene banked, right? We grew new cells, and that's got the DNA that we're going to use to gene bank, to clone with, because it's got your DNA. Okay, so once that's done, then we take this special slide that's got a metal strip on the top, metal strip on the bottom, and we'll hook it up to this machine that we've got calibrated, and it'll send electrical charge through that somatic cell and oocyte. So what I'll do is I'll line up 5 or 6 of these oocytes, and I'll put that somatic cell like at 6 o'clock or 12 o'clock, okay? And that way the electrical charge goes through them. And this is called fusion. You're essentially you're welding it to the cytoplasm. Now we'll go into some activation medias besides that, and we'll go into the incubator. But that's how it starts, okay? And we start out with a single cell. In about 24 hours, what you'll see cleavage. That's when life begins, is whenever the single cell actually divides in half. That's called cleavage. And once it's cleaved, then we know we got a live embryo. All the other embryos that didn't cleave at this point, or oocytes, are dead, or we're kicking them out. We're discarding all of them. So everything is now at this point on is cleaving, and these cells are dividing. And now this goes on for a couple days. Single cell cleavage. Now the cells are starting to divide 4 cells, 3 cells, or 4 cells, 8 cells, 16, and then they start compacting. So about day 5 is a compact morula. So that means it pulls in tight, really, 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 really tight. So if you're going to, this is day 5, day 6 on a deer. If you're going to freeze the embryo, now's the time to do that. And then at some point, it starts expanding back out. And what you'll see the zona, that's the outside ring, get really, really, really thin. And then in a ruminant animal actually hatches. It hatches and elongates, right? So we need to get it transferred before it hatches. The embryo goes down, blows back up, and in a ruminant, it elongates. So that's like when we're ultrasounding a deer or a cow. That's why we got ultrasound at day 30, because you can't see it because it's elongated. Like with a horse hatches, but it hatches inside another capsule, so we can see it at day 10. But the deer, or any ruminant animal, that's how it works. Okay, so over the years of cloning, we've developed a lot of different techniques on how to culture the embryos. We've cultured them in the incubator, and we grew them all the way out till they hatched, and which is a big deal. We're the first ones to ever do that, and that was like in 2010. That's a big deal. The first time, as far as I know, anybody's ever done that. But we had better success of culturing them. We cultured them in a rabbit. Yeah, it's okay. We cultured them in goats. So what I would do is I would transfer, say, 30 of them into the oviduct of a goat. And then it takes about 5 days, 6 days for all those embryos to get through the oviduct into the uterus. And so that 6 days later, we would take that same goat, and I'd flush all the embryos out of that goat, and then I'd pick out my best embryos and would transfer those into deer. I even did that in cattle, and I've got some of the cattle we cloned for West Texas A&M. That's how we cultured them. So the culture part is a big deal. If you're off by the culture, then you're off. But I've even developed better ways of culturing the embryos since then and transferring them that was really successful. And when I say successful, so I'd say the embryos are produced, 50% of them made embryos, 50% of them made pregnancies, and 50% of the pregnancies went on to be birthed. So I had it dialed in pretty tight. So say if you come to me and you said, I want 4 of these babies, then I could kind of dial it in. I knew how many embryos I had to produce your 4 offsprings. Here is a picture of my very first successful embryos grown in vitro. That means in the incubator. I know it doesn't mean anything to y'all, but it's a pretty big day for me. Okay, so now we produce the embryos, right? So we have to have our RECIPs, which is our surrogate moms, have to all be synced up with our embryos, right? So how do we get a bunch of deer synced up? Well, number one, we get them in, we get the RECIPs in, we put a cedar in them. A cedar it's a vaginal implant, and it releases progesterone, which stops them from cycling for 2 weeks. We leave it in for 2 weeks. We pull the cedar out. When we can leave it longer. We can leave it, 14, 16, 17 days, 18 days. But what we do is whatever day we're cloning, I want that deer ovulating that same day, right? So I pull the cedar and give her a shot, and she'll ovulate 60 hours, 55, 60 hours after I pull the cedar and give her a shot. So I'll do that before we produce these embryos. I'll have to be doing that simultaneously while we're cloning. So that's important to have these deer lined up. And then we go in there and we got to determine before we transfer the embryos that the deer are synced up. Okay, so now we're at the point where we're going to transfer the embryos. We don't know if the deer ovulated or not yet. So we bring the deer in, we'll give her a shot to make her go to sleep. Once she's asleep, we put her on a cart. So we put her on the cart upside down on her back, right? Go in there. We do a surgical scrub on there. We do everything's laparoscopic. We go in there laparoscopic. I go in there with my scope, and the first thing I'm looking for is if she ovulated. All right. So remember on those ovaries I showed you earlier, the little black dots. Well, what happens is those black dots fill up with follicular fluid, and then they bust. It's like a big old nasty zit, but that's how it releases the oocyte. Of course, we don't want their oocytes, but we need that CL or CH class CL to go to produce the progesterone to keep the pregnancy going, right? That's why we synced her all up. That's why we want her ovulating the same time the embryo's going at the same age as the embryo. So if we're putting a day 7 embryo in there, we want her ovulating 7 days ago, right? So I got to make sure that she ovulated. So then, and I got to put it in. If she ovulated in the left horn, on the left side, I got to put the embryo in the left horn, right? So I go in there, and with my scope, I look left, I look right, I'm looking at the ovaries, and this is what an ovulation looks like. You see the big red zit looking thing? That's on the ovary. That's what produces my progesterone to the point where the embryo attaches to the uterus, and then the embryo says, hey, I'm here. Do not cycle again. You're done cycling. You are pregnant. That's what keeps the cycle going, right? If the embryo doesn't attach, okay, then it'll finally go away, and then the cycle starts over again. That's how you get this 21-day cycle or 18-day cycle, whatever the animal is. That's how the cycle works. They ovulate, it produces progesterone, and then the progesterone, there's no signal from the embryo, so it finally goes away, and estrogen comes back in, and we start all over again, right? All right, so here's our deal. Okay, we got the embryos in. And of course, deer can have twins easy, so we usually shoot for 1 or 2 pregnancies. And so now it's 30 days. So if we put in a 7-day-old embryo or a 1-day embryo, whatever it is, we count those days up to day 30, 31, 35. Because remember, I told you the embryo elongates. We can't see a pregnancy till once the fetus is at least 30 days out. So then at 30 days, I built a little probe for my ultrasound, and I go in there and I ultrasound them. And what I'm doing when I'm ultrasounding, number one, looking, are they pregnant? Okay, yes, they're pregnant. Then I'm looking, it's like, all right, how many heartbeats do we have? Do we have 1, 2, or 3, or, depending on how many embryos I put in there. So I'm looking for heartbeats. And then from that point on, then we're sorting them off, saying, okay, she is now pregnant with a clone, and she's carrying such and such clone. Okay? So here's a bunch of pictures of some clones, deer, fawns, just random fawns that we've done over the years. Here's a picture of some mule deer we've done. Mule deer are extremely hard. Whitetail a lot easier than mule deer. Some other things we have done, and I know it looks kind of weird, but it's a bad picture, but here's a whitetail with a mule deer baby. So this is, as far as I know, this is the first whitetail to give birth to a mule deer. And the reason we were doing this because we were thinking at some point we're going to be cloning an extinct or endangered species. So we'd like to have something close, but not, because if they're extinct or endangered, we can't get oocytes. So we have to have something close. So we were messing around with this, trying to figure out, can it be done? And if it can, this is how we're going to do it. So this is the first whitetail to give birth to a mule deer. So now everybody asks me, can you clone a clone? Well, yeah, you can. And so here's a neat thing that we did too. This is just another experiment. So I had this deer to clone, and the deer died. She died when she was 22 years old, which I didn't even know deer lived to be 22. The older you get, the harder the cells are to keep. You know, the SMAC cells just don't work as good. And the best way I can explain it is kind of like when you're born, you're a fresh newspaper, right? It's real easy to read. And then after a couple weeks, you got a couple tears, you got a couple smears, and so your DNA is not quite as clean as it was. But there's a way around that. And what we did is we produced one pregnancy, and from that pregnancy, we took the fetus. Okay, so the fetus is up in the top corner, and the fetus is the clone. Okay, and from that fetus, we gene bank that fetus, just like you gene bank the old doe. We gene bank that fetus, so it's a fetal cell line at this point, and then we use that fetal cell line to clone that old deer. So that's kind of cool. Okay, so I know it's been fast, but let's go back to the first video, the first picture again. Okay, because now you have been drinking out of a fire hose, and I'm gonna show it to you again. Remember, you got the donor, the cell donor. Now the cell donor up in the top right, she's the one you gene bank. This is your cow, this is your deer, this is your horse, this is your dog. This is the one we gene banked the SMAC cells on, right? Now over here, on maybe it's swapped on your TV, but you got the oocyte donor. Okay, the oocyte donor is the killer cow or the wild deer or whatever you don't need. We're taking the oocyte from the ovaries. Okay, so from each ovary you're getting from each ovary you're getting 10 or 15 oocytes. Now we are maturing that oocyte, and then we're going to remove that DNA. So that DNA, that oocyte, is essentially an egg with no DNA. Then we're going to take that somatic cell over here from our donor that we have plated and matured, and we're going to implant it in between the zona and the cytoplasm, and then we're going to infuse that somatic cell into the cytoplasm. The cytoplasm gives us our gas to grow the embryo until it attaches to the uterus. Then that is matured, grown. Remember how the cells divides, cleaves. We got a live embryo at this point, and then they keeps dividing. 4, 6, 8. Then divides on out, and then it compacts down. And before it hatches, we transfer it into what's called the recipient cow. Remember, this recipient cow is on the same page as the embryo. 7-day-old embryo, cow ovulated 7 days ago. Transferred into the uterus. She gets pregnant. She carries the baby to term, and she gives birth to the clone, which is an identical twin to the cell donor. It's easy. Okay? Everybody got it? Good. Watch the video again if you didn't. I'm sorry, it's fast, but I didn't want to bore you. So now here's where we're at with cloning. So the company that we had is myself and Dr. Veniclausen, who's a vet, and he's a partner in about everything we've done. We started a company. It's called Wildlife Reflections. We clone deer. That was all we did. Mule deer and whitetail. That was all we were doing was cloning. Well, the state of Texas, the Texas Parks and Wildlife has, and I saw this coming, they made a rule that I cannot clone deer in Texas anymore. So essentially, it's not my lawmaker making it. It's the douchebags, the executive douchebag. I think his name's Carter Smith. He's been there forever. He's a douchebag. Somebody's yanking his chain down there at Austin, and they made it illegal to clone anymore. Instead of letting the private market just settle about what businesses survive and what fails. And this was a business. I mean, it made, I charged $50,000 to do a whitetail, and I charged $75,000 to do a mule deer. So it wasn't chump change. I mean, I made money doing this. So all this equipment I've shown you, I mean, I'm selling it all. And you're saying, well, why don't you fight it? Well, let me tell you. I've had this deal. I've had the government go against me before, and when the government goes against you, you better just pack your toys up and go home, because you're going to lose. I don't care who you are. You can't outspend them. You can't win in the courtroom. You're going to lose. It's as simple as that. And especially these guys, So I'm talking about the executive guys. I'm not talking about your game warden. I'm talking about the Carter Smiths of the world. It's these guys down in Austin. So here's just a quick story, and I'll quit my crybaby stuff. Okay, so the second guy I was cloning for. We was cloning for this guy, and this is right when they shut the border down for Texas. Used to, you could bring deer into Texas, into a pen, and then they shut her down. Well, this guy had a pen in, I think, maybe Mississippi or somewhere. Well, he brought a deer across the state line. Texas Parks and Wildlife caught wind of it and approached him about it. He goes, "Yeah, this is the deer. I snuck it in, after the deadline." Well, so what they do, they go in there to his pens and they kill every deer in his pens. He had the best deer at that time in Texas, had some of the best deer. So it was like probably, this is 10, 12 years ago. It's probably $3 million worth of deer in his pens. They went in there and shot every damn one of them. Then they go in there and they fine him $1 million. They're not done. This guy, then they cut him some slack. Since he's 80 years old and he's got terrible health, instead of throwing him in state prison, they give him house arrest for 4 years. And this guy, everybody loved this guy. He's a super nice guy. And he had a business there in this little bitty town. I think he employed 650 people in this little business he had. And so, yeah. That's what you say, why would you do that? Why would it? I know it's their version of like trophy hunting, to have somebody they can hang on the wall, but why would they? And the only reason I come up to is because they can. And so when you see me saying I'm not going to fight them, I'm just done, I'm packing my shit up and I'm going home, I've seen what they can do. And I know I can't win anyways. So yeah, but hey, on a different note, the horse that we're naming, we got about 1,000 different names for the horse. The next video, one after this one, we're gonna pick a name, and we got a lot of good names. So, anyways, all right. Well, thanks for following me, and all you guys. I know y'all got a bunch of people that like to know about cloning. I had about 600,000 comments wanting to see more about cloning. So make sure you share this with all you people about cloning. And I don't know, I'm sure you got 101 questions. I tried to keep it really simple. There's a lot more to it than what I explained, but I tried to keep it to, just straight and to the point. So thanks for following me. Thanks for subscribing. Thanks for watching. See you.